All of you open up the write-up. Okay, are you able to see this write-up on the screen?
Yes, sir.
Okay. So today we are going to do the experiment on longitudinal vibration of helical spring and to determine the frequency and time period of oscillation theoretically and experimentally. Okay, so this is the procedure. Okay. Now before you do that, let me explain what the experiment is about. So you have your spring mass system, and you have to find the natural frequency of that spring mass system theoretically and experimentally. Okay. All right. So the setup for the experiment will be a spring mass system. So we have a spring mass system. Are all of you are able to see the presentation screen?
No, sir.
Okay, let me just.
It is loading, sir.
Okay.
Yes, sir.
Okay. So this is a basic setup for the experiment. So you have to find the natural frequency of this system theoretically and experimentally. So theoretically, natural frequency of the system is given as square root of k by m. So first thing you have to find out is the stiffness. All right, and you have to attach the mass to the spring mass system and then give it some oscillations. Okay, find time for 10 oscillations, then divide that total time by 10. That will give you time for one oscillation. All right, time for one oscillation, and reciprocal of that time. So this is, if this is t, and f will be 1 upon t in hertz. Right, so that's how you are getting it experimentally, and you have to substitute k and m in this equation divided by twice pi, that will give you theoretically. Okay, so both methods should values by both methods should match for a particular mass. Okay, so that is what the experiment is about. Now, before you do the experiment, just open up the your assignments. In your assignments, there are some instructions which are given. Assignments. You have to open up the assignment in your lab. See, all the lab work has to be submitted in these separate teams which are created for the lab. Okay, so is your TMEC B2 batch 2021, that is a batch for your assignments. Okay, so in that, open up the assignment, and it says lab number 3, natural frequency of spring mass system. Just open up that assignment. Has everybody opened that assignment? All of you have got the assignment. Like, are you able to locate that assignment?
Yes,
Yes,
sir.
sir.
Okay, so if you see that instructions, some instructions are given. So first thing is to create a mathematic. So you have a spring mass system. So first we'll do some theoretical analysis. So you have your write-up. So in that write-up, you will be entering the data for the experimental part that that I will give you from the video. So before doing that, you have to do some theoretical background. So this you have to attach as a supplement to that write-up. Okay, so all this part you write it on a separate piece of paper and attach it with the experiment write-up, and you have to also submit a scan copy of that after you complete it right now. Okay, so first thing is what, creating the mathematical model for the experiment. Okay, for the experimental setup. So your experimental setup is nothing but your spring mass system that I have just showed you in this PowerPoint, and I will also show it on your video. Today we will be doing our experiment. All right. So this is the basically the setup. Experiment on the logic. All right. So this is the spring mass system on which you will be doing the experiment. All right. So that part we'll do later. So first thing I want all of you to do is go to this lab assignment. All right. So create a mathematical model for the spring mass system. All right. Once the mathematical model is created, derive the governing differential equations. So that you have to do by two methods. I use the D'Alembert's principle as well as the energy method. Okay. Then solve the governing differential equation. Okay. So do up till these steps, and once you get the governing differential equation, take a photograph of that and scan it and upload it. All right. After that, we'll start with the actual experiment. So for that, Now the time is 1:25, so you have like 15 minutes to complete this part till point 3. Is everybody clear?
Sir, could you please repeat?
See, just go to the instruction section. So instruction section, first point is create the mathematical model for the experiment, all right, or the experimental setup. So what our experimental setup is just a simple spring mass system. Okay, so first step is to create the mathematical model for that. After you create the mathematical model, derive the governing differential equation as we used to do in our normal method. Okay, and you are required to derive this governing differential equation by two methods. One is by D'Alembert's principle and second is by energy method. So use both the methods and you should get the same governing differential equation. After you get the governing differential equation, solve the governing differential equation. Okay, once you are ready with this, once these three steps are done, scan the solution in your mobile and upload it on the assignment. Is that clear?
Yes, sir.
Okay. Once that part is done, then we will start with the actual experiment, and then we will see what are these remaining points that are to be done. Everybody has access to Excel. Anybody who doesn't have access to Excel, the time is 1:25. So 1:25, I give the task. We have 15 minutes to complete it. So 1:25 to 15, so up till 1:40. All right. So till 1:40, you submit the first 3 points in your assignment.
So,
Yes.
to for the first point, the mathematical model one, we just have to draw the diagram, right, of the spring
Yes.
mass.
Yes.
Okay, thank you, sir.
And write the like all the right, draw the free body diagram, basically draw the actual diagram and convert it into free body diagram with
Okay,
showing all the forces.
okay, thank you, sir.
And for each step write what is what, like you have to state this is which step, just as you did it in an exam. Each step should be clearly marked. See, I have also uploaded the write up for first two experiments. So no, some of the data was uploaded in that common team which is for your class, that is uh, T make DOM uh, T make B DOM 2020. So don't, if you have uploaded anything, it download it from there. So for all the lab work, all the data should be uploaded for this assignment. So at that time the what is it, the batches were not created. So the teams for the batches were not created. So whatever is relevant to the lab work, this should be uploaded in this team only. That is T make DOM B2 batch 2021. So you, if you uploaded your what you say, completed write up in the earlier team, just download that PDF file and upload it over here.
Sir, can you please show the question again, the diagram?
If you are done, you can submit the assignment. Submit the assignment part. I mean, that a part of the. All right. Have you uploaded the?
No, sir, just 2 minutes more.
Sir, I have uploaded 112.
Okay. I'm going through it one by one. All right. 2 more minutes. After that, I'm going to start with the next section. So 10 marks are for this derivation.
So we have to upload it in lab 3 in natural frequency only, na?
Yes.
Okay.
So this portion has 10 marks. All right. Moving on to the next section. So the time is now, cutoff time is 150.
Sir, 2 minutes, sir. We
Yes.
just need to upload.
Upload it fast. All of you open up the write-up. Those who have, I need all the students to open up the write-up. Okay. So I'm just going through it one by one. The aim of the experiment to study the longitudinal vibration of the helical spring and to determine the frequency and time period of oscillation theoretically and actually by experiment. Okay. The experimental procedure that I will discuss in the video. All right. So I will start with the experiment. All of you are able to hear the audio.
Yes,
No,
sir.
sir. What audio?
The audio for the experiment.
No, sir. I can't. I cannot
Sir,
even
share
see
your
anything.
screen.
Pardon?
Yes, sir.
Share your screen, sir.
Just a minute. Just a minute. How about now? Are you able to hear now?
So the audio is not there.
Sir,
It's not
video
clear.
is freezed.
Video is visible, but not able to hear any audio.
Okay. in the experiment is be doing our experiment. How about now?
Yes, sir. Yes, sir.
Yes, sir, it is audible.
Longitudinal vibration of a helical spring with a. I will just begin from the. I will restart the video. Today we will be doing our experiment on longitudinal vibration of a helical spring with a spring mass system. Okay, so to begin the experiment, first step in the experiment is to find the stiffness of this helical spring. Okay, so alright. So in your write up, which I am simultaneously also show the write up. See, in the write up, first part of the calculation is the calculation of the stiffness. So I am now explaining how to calculate the stiffness of the spring. Okay, simultaneously keep your write up open. Okay, so this is a helical spring. So first thing is we are going to find the stiffness. So to find the stiffness, we are going to measure the initial length of the spring. So go ahead and measure the initial length. And the scale one number. Hey, Amma, hey, this is the malakad. 7. So how much is the length? 7. 7 centimeter, no? Meter. Meter के सीरी. 7 centimeter. Alright. So the initial length of the spring is recorded as 7 centimeter. Alright. So all of you in your rough journal note down the initial length of the spring. You are able to hear my instructions, right?
Yes, sir.
Okay. So step by step, whenever I am make it a point, you give the instruction. So note down the corresponding what you say reading in your rough journal. Okay. All right. So I will continue. So all of you please make a note of it. All right. So that is the initial length. Now some mass will be attached. All right. So this is a mass of 1 kg. All right. So a mass of 1 kg will be attached to the spring now. Alright, so this is a mass of 1 kg which is attached to the spring. Okay. Now again the length of the spring is measured, will be measured.
Sir, could you please tell what was the initial length of the spring?
See, in your class materials, so whatever you miss in your class material folder, so in your assignments, in the resources, I have given the link for the experiment. Okay. So right now, just try to understand the procedure. If you miss anything in between, you just see the video again. All right. So now it is 9 centimeters. So the stiffness of the spring will be. Alright, so initial length, now this is the final length, that is 9 centimeter. So find out the difference between the final and the initial length. Load per unit change in length. Right? Okay. So load is 1 kg. So stiffness is W by del. Alright. So find out the stiffness by using the equation W by del, that is load per unit deflection. So W by del will be the stiffness of spring. So that you have to calculate. The weight attached is, that part of the calculation has to be entered in your manual. Okay, right now you add it, write it in your rough journal, but when you submit later you have to take the printout of this write up and then enter all the values in this write up. All right, let's continue. Okay, the next step will be to calculating the now next what we are going to do, we are going to give some oscillations. Okay, now you have to measure the time for, say for example, if I want to measure time for 10 oscillations, so measure the time for any 10 consecutive oscillations. See, I might in the video there the mass might have 15 or 20 oscillations, so you don't have to measure the time for all the 15 or 20 oscillations. Find out the time for 10 oscillations and then divide that time by 10, that will give you time for one oscillation. All right, is the procedure understood? All right. So from the manual, see this is this observation table. All of you are able to see that observation table 4.2. Varshil.
Yes, sir, we are able to see.
Yes, sir.
So in this observation table, there are three readings, serial number 1, 2, and 3. So for first reading, the weight is 1 kg, and you have to find the stiffness for that. So stiffness will be remaining same for all the three readings. Okay. Then find decide what will be n. So for example, if you take n as 10, then write here n as 10. Okay, and then write down the corresponding time t. All right.
Sir,
So
T that we have to write is for the number of oscillations or one oscillation.
no, here first write for 10 oscillations, then see here you have the calculation table, right? So calculation table, you have to write the T actual. T actual will be T divided by number of oscillation. Time for 10 oscillation divided by number of oscillation, that is 10. All right. So that you have to write in the calculation table. So T actual will be T divided by N. All right. So that you have to write for all the three weights. Okay. T theoretical will be twice pi into root of m by k. Here W is in terms of kgs divided by k. All right. So that will give you T theoretical for all the three. All right. So take reciprocal of that. That will give you F theoretical and F actual respectively. Right. So first prepare this observation table. All right. Once this observation table is prepared, then prepare the calculation table. Okay. Can we continue with the experiment? Now we have to record the time. Now starting with 1 kg. Okay. Is 1 kg plus you have to also add the weight of the bolt, that is 50 grams in each of the readings. Okay. So now, so total weight will be 1 kg plus 50 grams. After this is done, we are going to give the oscillations to this mass. So first reading is for 1 kg plus the mass of the bolt. So it gives so we are going to give some displacement to the mass, and you are going to record time required for 10 oscillations or 10 vibrations. Okay, so give some vibrations. Time होगा नहीं time they will measure करो हाँ सांभाळो नहीं तू stop नको करू ते let it vibrate huh? So again we'll record. Okay, 10 जास्त आहे. Okay, now stop it. Stop it. All right. All right. So now this was for 1 kg mass. You have to record the time for any 10 consecutive oscillations. All right. You don't have to count the time for all the oscillations. Just measure the time for any 10 oscillations or any 15 oscillations, whatever is convenient to you. That I leave up to you. How many oscillations you have to you are going to count? That is up to you. You have to divide the
Sir,
total time. Yes.
50 gram is of means whose weight? 50 grams springs.
No, 50 gram is the weight of the bolt.
So then we will have to consider the weight of the bolt for the natural frequency of spring also, no?
Yes.
Okay.
Everywhere you have to add 50 grams. In the even in the stiffness equation, you have to add 50 grams.
Okay. Thank you, sir.
Okay. All right. So this was for 1 kg. So now you have to measure the time required for any 10 consecutive oscillations. All right. So that is your first reading. Now we are going to replace this 1 kg mass by 0.75 kg mass. Very bold. So now the weight attached is 0.75 kg plus the mass of the bolt, that is 50 gram. Okay, now again we are going to give some displacement to the mass and again measure the time for any 10 consecutive oscillations. Okay, so go ahead and give displacement. Okay, stop. Alright. So we have recorded more than 10 oscillations, but you have to record the time for, so or you can record any n number of oscillations and divide that time by the number of oscillations you have measured. Right? Okay. So this is the second reading. Now remove the
Mass
mass
being
and
added is
we'll again repeat the experiment
0.75 kg, na?
Yes.
Okay, okay.
For 0.5 kgs. Okay. Again give it
So
some
this is your
displacement.
third reading.
Convection oscillation. Okay, stop it. Alright, so that is how, as far as the performance experiment is concerned, that's it. Now, rest of the explanation I will give you during your practical session.
All right. Now, if there is a lag in video, see in the assignments under the resources, I have given the link for the video. All right. So you have to measure the time from the video by playing the video at your end. Is that part clear?
Yes, sir.
Yes, sir.
Okay. Now you have to complete 4.2, 4.3, and the calculation table. All right. So do this in your rough journal for all the three readings. So one is for 1 kg, 0.75, 0.5 kgs. So for all these three weights, do all these calculations. You have to do the spring stiffness calculation only once, because the spring stiffness will not change for different masses. Only the time for oscillations will change. Okay. After that, you do the calculation, complete the calculation table, scan the image, and upload it.
Sir, for third iteration, the mass is of how many kgs? Means 0.8, na?
0.5 kg.
0.5, okay.
1 kg, 0.75 and 0.5 kg plus the weight of the bolt, 50 grams.
Okay, sir.
Alright, so I will give you 20 minutes to complete all these calculations. So submit all these calculations by 14:25. Then we will see about plotting of the graph.
Sir, sir,
Hello, Varshil. Hello.
sir,
Yeah, you are saying
sir,
something.
sir. For the value of k, we have to consider the mass of bolt also.
Yes.
Sir, sir. So the for second mass we took 0.75 kg. So its value of k would be different, no?
No, the spring is same.
Okay, okay, sir. So, okay, sir. No problem. Thank you.
Okay.
Sir, where is the video? Means in the Teams file there is no option.
Hello,
Yes.
Sudarshan. Open your assignment.
Sir, where you are uploading the video? Means in that track file there is no video.
No, no. Just have you opened the assignment?
Yes, I open.
No, in the assignment, can you see the titles? Something called as resources, reference material. Reference material. It says. Can you see reference material?
Okay. Yes, is that SharePoint, na?
SharePoint. Yes.
Okay. Okay, sir.
Sir, excuse me, sir.
Yes.
Sir, I had a doubt. When
Just
we
a minute.
change the weights,
Go ahead.
sir, when we change the weights, won't the extension in the spring change? How can we
Yes,
assume
but
that?
yeah, how can we assume?
How can we assume that delta will be 2 centimeter for all the three cases?
No, no, it is
Because
not. Delta is not. See, what is stiffness? Load per unit deflection. All right. So as you
okay.
change the load, the deflection is going to be different. But
Yes,
the
sir.
ratio is
But we did not measure it all the three times. No.
yes,
Initially it was 7 centimeter, and then we know it was 9 centimeter. But for
yes.
the rest of the two cases, we don't have the length.
But it is safe to assume that because the spring W by del, that ratio is constant, right? For a given property, for if the material is constant, if it is the same spring of all the design is
Okay.
same.
So we assume the K to be constant.
Yes, you have to. It is safe to assume that the K remains constant throughout experiment.
Okay,
There
sir.
is no
Okay.
reason to suspect that K is going to change
Okay, sir.
unless there is change in the design parameters of the spring, like the coil diameter or number of turns. All these things are remaining same. So you can safely assume that the spring stiffness remain constant for all the three readings.
Okay, sir.
Sir, for calculating, do we have to calculate K for all the three cases for
No,
theoretical value?
no.
K you have calculated once, same K is to be used for all.
Okay, sir.
Hello, sir.
Yes.
Sir, for T actual, I'm getting 0.1 second more for every mass value.
So what are the values theoretical?
So theoretical is for 1.05 kg, it is 0.283, and actual I'm getting is 0.364.
0.283 and 0.36.
Yes, sir.
But this you are getting this error consistently.
Yes, sir. For every mass value, I'm getting zero point 0.1 second more than the theoretical.
All
Sir,
right. Let
even
me.
I am getting similar difference.
Yeah,
Oh,
same over here.
Yes, sir.
okay,
Even I am.
that is fine. That's fine.
Sir, so we just fill the values we are getting.
Yes.
Okay.
Sir, where do we have to submit?
Just unturn and just submit it. Unturn your
Sir, we have to
submission.
them or single this only now.
You can submit it separately. This part.
So, sir, it will be how will both of them come? Only single file will come. No?
No. You are allowed to submit more than one file. You are submitting more than one file. No?
Yes, sir.
Sir, what exactly do we have to scan and submit?
The calculation, that observation table calculation and calculation table.
Okay.
So we can add this calculation page to the previous document itself. Uh, will that be fine?
No. To attach it separately.
Okay.
Alright, have you submitted?
No, sir. 3 minutes, sir.
Only one student has not submitted. Okay. So all of you have submitted. Now there are two things they are remaining. Now just go to your what you say assignment and open up the what is just hold on a minute. Open up the fourth resources. There is a quiz. So just read the quiz question and submit it.
So where is the link?
See in the assignment in the resources section, the fourth resources. First one is the lab manual. Second one is the link for your video. Third is for the graph. So don't open that link right now. Open the fourth one, the forms.office. All right. So there is a quiz. Uh, just read the quiz and submit the answer. You have 15 minutes to complete the quiz. It is 1:30 right now. All of you have submitted the calculations, right? The rough journal calculations is 1:30 right now.
Sir,
Yes.
sir, I am submitting.
Submit fast. You have till 1:45 to complete the quiz. The fifth question is enter the value of natural frequency by the method chosen in question number 4. I have updated it, so some of you might be seeing it as question number 1. It is not question number 1, it is question number 4. That is the earlier part, earlier to question number 5. Okay, so type in your answers and submit it.
Hello, sir.
Yes.
Sir, for the fifth question,
Yes.
natural frequency, we have to put in the theoretical or the actual.
Yeah, go ahead. Just repeat the question. Can you repeat the question?
Sir, for the fifth question, we have to put in the natural frequency. So we have to put in the actual or the theoretical one.
No. Just read the. You are talking about the quiz, right?
Yes, sir.
Okay. Just read the quiz. Have you read the? Have you sub? And read the question carefully. Enter the value of natural frequency by the method chosen in question number 4. All right.
Okay, sir. But in the quiz, it is written question number 1.
Just refresh it. I have updated that. That is what I was telling. It is not question number 1. It is by the method. See, all of you, please pay attention. Question number 5. You have to enter the value of natural frequency by the method chosen in question number 4, not question number 1. Okay. I have updated that. Just do a refresh. Is that clear to all? Do not answer that question wrongly. Those who are done can submit the response. Has anybody submitted the quiz?
So we need more time.
Okay. I will give you till, so it is, earlier I told till 1:45, so I will make that 1:50. It is almost, sorry, not 1:45, 2:45. So I will give you 5 more minutes, make it till 2:50.
Sir, in the question for it is written that natural frequency by the method you choose, but for the every 3 reading, the natural frequency will change. So we have to specify the reading also, no?
See, you are not reading the question. Okay. What is question number 4? What is question number 4? In addition to the methods described in the experiment, can you suggest?
Sir, I have understood question number
Sir,
4. I'm
for the
talking
method
about
we are
question number 5.
suggesting, we
Just hold on a minute. There was a lot of disturbance. Okay. So first, let me complete the question. In the addition to the method described in the experiment, can you suggest any other method for calculating the natural frequency for any of the readings
For
taken?
question number 5, I'm asking.
So question number 5 is what? enter the value of natural frequency by the method chosen in question number 4. Alright, so in question number 4 you will arrive at some method, right? So whatever method you have, you think is in addition to the one which you have described in the experiment can be applied, that using that method you calculate the natural frequency and enter it in question number 5.
Sir, okay, but we have 3 readings, na? So each reading mass is different, so natural frequency will be different.
See, you are not understanding the question. It has nothing to do with your readings. You have to tell me about a method other than the method which you are used in your calculations and readings.
Sir,
Okay.
but for the method we are suggesting, we know only the value for one reading of
Whatever it is, you write it. So I see. What is written in the question? Is it written for all the readings, for any of the readings taken?
sir. So should we put in the
Yeah.
circular
Don't try.
frequency?
Don't tell the answer on the audio. Whatever you feel, you describe the method. How will you calculate that?
Sir,
What?
I am not telling the answer. I'm asking if you have to put the circular frequency or the uh, longitudinal one.
What do you mean by circular frequency?
The unit should be in radian per second or
Hertz. Put it in
okay.
hertz, because then only you will be able to compare with the answers which you have got, right? From you have already got a theoretical answer, you have already got an experimental answer. So I am giving you one more method. I am suggesting you use one more method and just compare the answers which you are getting by this earlier two method. Is the answer comparable?
Okay, sir.
Okay.
Sir, the value of frequency of which of the mass?
Huh?
Value of frequency of which mass?
You are asking me this question with reference to which what, like what is the question with reference to what?
Sir, we have to find the value of frequency in fifth question, right? But which mass we have to take?
That you have to decide, na?
Sir, any of them we can take.
Okay, then do it for any of them. Accordingly, you state it in your answer.
Okay, sir.
All right, submit your answers. We have to do the graph part also. Yes, I'm closing the quiz now.
Sir, wait for a minute.
Excuse me, sir.
Yes.
Hello.
Yeah, go ahead. Hello. 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 Are you able to hear me?
Yes, sir.
Yeah. Somebody was asking me something. Hello. Some student was asking me something. All right. Submit your responses. All right. I'm closing the form now. Hello. Now no time will be extended. Whatever answer you have, you submit it. Otherwise, you won't get any partial credit also. Once the form is closed, it will not be open. All right. I'm closing the form now. Because last 15 minutes you have to spend on the graph. All right, the responses are closed now. All right, I'm not accepting any more responses. All right, now just let's review the quiz. All right. So, what are the type of vibrations studied in the experiment? Some of them have written longitudinal vibration. So that is free undamped vibration. Longitudinal vibration is also okay. Like the question was not very specific, but the expected answer was free undamped vibration. Some of your written longitudinal vibration, that is also I am accepting that answer. Okay. What will be the nature of steady state response? It will be a cosine wave. Okay. Transient component, there is no damping, so there will be no transient component. And any other method, the other method you can use is you can use the static deflection. All right, static deflection you have calculated for, and that you can do it only for the 1 kg mass, because you have calculated the static deflection only for that. All right, so the value you are getting, is it comparable with the value which you got for from your other two methods?
We can also do it by Rayleigh's method, no?
Rayleigh's method. Yes, you can do it by Rayleigh's method.
Okay.
How will you do it by Rayleigh's method?
So we will first do it theoretically. The answer will come root of g by delta. So we have static deflection.
Okay, so ultimately you are going to use a static deflection. Okay, so is the answer coming same?
Yes, sir. Exactly
Okay.
same.
Yes.
All right. So
Sir,
you can verify the answer by
so
using
steady
the
state response, the answer can also be sinusoidal, no?
It can also be sinusoidal.
Okay.
In that case, the phase lag will be, phase angle will be how much? Yes,
Plus 5.
plus 5. No. So
How
suppose
can
phase lag is 0. All right, phi is 0. So if I want to write it in sinusoidal form, then what will be the equation?
Sir, I had a doubt.
Yes.
So in the first question, you told the answer would be free undamped, but since we are performing this practically, we have to consider air resistance, na? So it will be longitudinal only, or free
Yeah.
damped.
But have you considered the air resistance in any of your equations? In the derivation, have you considered, have you derived it for damped
No,
vibration?
no, sir.
You are not considering.
Sir, so can this be a reason that we are getting a variation in theoretical and actual values?
There may be so many. There are so many sources of error. It is not done like in the most professional manner. There might be errors in the measurements. So many things are there. So the damping thing might it not affect the result that severe. But there are other sources of error that might affect that might cause serious error. Measurements error, human error are the most severe reasons for the error. All right.
Sir,
Yes.
so sinusoidal means cosine or sine, na? Means both are there.
Sinusoidal means sine. Cosine means cosine.
sir,
Okay.
sir,
Okay.
why do we need to consider only the first weight? Why
Because we have calculated the
not
static
the
deflection.
second?
You don't know the static deflection for the second and third weight, na? We have calculated the static deflection only for 1 kg mass.
Sir, but mass of that bolt is also there, no? So none of them will come.
No. See, even with the mass of the bolt, for that you have considered, na? So you have taken into account that weight of the bolt in your reading.
Sir, so for static deflection, we won't consider that bolt,
No,
mass of bolt.
it is being considered whether you want it or not. The static deflection will be, take. It will happen because of the bolt, na? The bolt will also deflect the spring statically. It is not up to you. What you are measuring is the static deflection. That is initial length minus final length minus initial length. So in that case, the bolt is deflecting the spring, right?
Okay, sir.
So all right. So that takes care of the quiz. I will review the answers individually. Now the last part of the experiment is you have to draw the graph. Okay. So the last part of the experiment is results. Okay. So we are going to do a result interpretation. So your solution for the equation is what? X is equal to a cos omega t minus 5, right? Is that correct?
Yes, sir. Yes.
Where a is the amplitude of vibration, okay, and omega is the natural frequency, omega nt minus phi. Now assume that phi is equal to 0. All right. So if I want to plot the displacement with respect to time, what should I get? I will get a cosine wave. All right. Now the cosine wave, when I start it from t is equal to 0, at t is equal to 0, the amplitude is going, the displacement is going to be maximum, that is equal to a, right? Now for the sake of drawing the graph, take a is equal to unity. All right. So we are going to scale the graph by the magnitude of the.
Sir, share your screen.
No, I am not actually doing anything on the screen. I'm just describing what is to be done in Excel. Okay, I will share the screen. All right. So what you're going to do is you're going to prepare a graph.
Hello, sir. Are you there?
Yes, yes. Are you able to see the screen?
Yes, yes.
All right. So for
Yes,
the
sir.
so your response is what? X of t is equal to a cos omega nt minus 5, right? Okay. So take phi, that is phase lag, is as 0. All right. So now your equation becomes xt is equal to a cos omega nt, right? Okay. Now you have to plot a graph. So column 1 will be time t. So t is on x axis and xt is on y axis. All right. So t on x axis, xt on y axis. All right. And so what do you expect the graph to be? It should be a cosine wave. All right. Now since phi is equal to 0, at t is equal to 0, it should start from maximum. That is, at t is equal to 0, it should be a. This displacement should be a, right? When t is equal to 0, x of t is equal to 0 will be a. All right. So for simplicity, we don't know the actual value of a. So let's take a as unity 1. Okay. So what we are going to do is we are going to scale this graph by a. We are going to divide the entire values on this graph by a. So this becomes 1. All right. So at t is your graph should start at t is equal to 0. Displacement should be 1. All right. So at t is equal to 0, displacement should be 1. All right. Okay. So now go on increasing the value of t incrementally by very small values and calculate the corresponding value of x of t over here. You already know omega n. Okay, so choose any one of the reading. Choose any one reading. All right, and generate a graph of t and x of t. So just you have to add some small values incrementally to this 0, and correspondingly you have to get x of t. So x of t will be cos of omega n. Omega n is from your reading and t is from this column. All right, so you have to generate these values in Excel. After you generate, so this you have to do it in Excel. All right, after you do this in Excel, you have to plot the graph in Excel. All right, how to plot the graph, how to do these calculations, that all this part has been described in this small video which is attached in your assignment. That is the third video, the YouTube video. All right, so open that video and see that video, and that will help you to plot this graph. Any questions on the last part?
So do we have to submit the graph right now because
Yes,
we
it is.
haven't?
The video is just of 2.5 minutes, so you have more than 5 minutes. So try to submit it before the end of the practical. Otherwise, you can submit it later also offline. If you are able to finish it within 5 minutes, fine. Otherwise, submit it later also. Whenever you finish it till today, you can submit it. All right.
So what should be the time step?
That the time step, everything is given in that video. You just go through that. You have to choose a very small time step. so that you get enough number of points to plot the graph. All right. So plot the graph for one cycle. Accordingly, choose the time steps. Right. Any other question? So today's rubrics I am telling you for today's experiment. All right. 10 marks for governing differential equation, 5 marks for graph, 5 marks for quiz, and 5 marks for the write-up. All right. This is how the breakup is going to be. All right. Total is 25. Okay. So generate the graph in Excel and upload it as a response to this assignment. Again, do unturn and submit the. Any questions on the assignment part? Is everybody clear what is to be done?
So what do we have to submit?
You have to submit the graph, the Excel sheet.
The whole Excel sheet, right?
Yeah, prepare the graph on the Excel sheet and then submit the Excel sheet, entire Excel sheet. Yes.
Sir, we
So
have to
we
take.
have to make both the cos and sine graph.
No. Now here your solution is in terms of cosine, na? So why to draw both the graphs? Just the cosine graph. That under this condition, phi is equal to 0, take a is equal to 1. So it is scaled by a. Your output is scaled by a. So it is not xt, it is xt by, it is in fact xt by a. Alright. On y-axis, it is not in fact xt. It is a dimensionless quantity of xt by a, but you will be able to interpret the result from this.
Sir,
Yes, and draw it for one cycle.
sir, for we need to upload the Excel folder, or we have to take a snap of it and.
No, Excel sheet you have to upload it.
Okay.
Save the Excel sheet and upload it. Write your SAP ID, save the file name as SAP as your SAP ID and upload it. So today you have to upload 3 things. First was the derivation part, second was the rough sample calculations, and third is this graph. Okay, so and fourth one was the quiz that you have submitted. So all things should be done. If you are not able to finish it, it is almost 3:10 now. So if you are not able to finish it by 3:10, then you can complete it later today and submit the graph. And don't wait for me to announce the date of submission. As soon as your write-up is complete, you have to immediately submit it. So that I can evaluate it at my end.
So what about the write-up of the second experiment?
So I have given the write-up. See, I have created an assignment that is called lab number 2. If you see the list of assignments in the team, see lab number 2, find the MI of a irregularly shaped solid body using trifilar suspension. Alright, so I have created that. So you should see the lab number 2. Okay, just open that PDF. That is your second line here. So do not write it in the portrait format. I have just given the, I have given you the presentation. You can write it on the plain sheet as you normally do in sequence. If you have journal pages, you can use the journal pages also. That is also fine. Or just write it neatly on a full-scale paper. That is also fine.
Sir, and what to write in this experiment?
Which one?
A third experiment.
Third experiment, I have given you the write-up, na?
So we have to take the printout.
Yes, take the printout, write all the calculations in the write-up. All right, there is one part for diagram. In addition to that, you attach the derivation, then the graph, and what do you say? What was the third thing we did today?
So for the second one, we have to write everything, or can we print the theory that is given?
See, take the printout of the write-up. All right, the calculation part you have to write by hand. Whatever is blank, rest you can keep it as it is. Just read it.
Sir, for the second experiment, we had already uploaded the proof. So do we have to do it again in the fair write-up?
No, not again. You can just arrange the PDF, na.
Okay, sir.
Arrange the PDF in the sequence given in the write-up. You don't have to again write it. Just arrange it in that sequence and submit it. So whatever submission you have to do now, you have to do it on this team. If you are, last, I think during the first practical, the team was not created. That's why I've asked you to upload it in the class team. So that I'm going to delete it. Okay, from there. So before I delete it, you make sure that you download all the material that you have uploaded and upload it here in this team. All right. Okay. Any other questions?
So for plotting the graph, do we have to use theoretical value of omega n or actual value?
Use any one value. Right. Either use omega theoretical or omega actual. The both are almost same, right? All right. Any other questions before we end the session? All
No,
right.
sir.
All right. Complete your work and upload the stuff, and that's all for today.